Okay, let's dive into this. Welcome to our latest explainer. If you're gearing up to master the core concepts of industrial health and safety, you have landed in the exact right spot. Today we're taking a comprehensive academic exam paper and transforming it into your ultimate industrial safety study guide. We're going to break down the definitions, the protocols, and all those absolutely crucial concepts you need to know. So get ready to focus because this explainer is designed to make your learning highly efficient and completely accessible. We're pulling this study material directly from the Faculty of Technology at the General Sir John Kotilawala Defense University, specifically their exam for the Bachelor of Engineering Technology in Building Services. And hey, I want to emphasize right off the bat, these aren't just dry theoretical textbook ideas. These are the rigorous, real-world standards used to test and qualify our future engineering and technology professionals.
Here is our syllabus roadmap for today. 1. Foundations of safety. 2. Preparing the worksite. 3. Identifying hazards. 4. Mastering PPE. And 5. Workplace culture.
Starting us off, Section 1, Foundations of Industrial Safety.
Let's kick things off with a literal Jeopardy-style question straight from the multiple-choice section of the exam just to test your baseline knowledge. Ask yourself, what is the absolute primary goal of health and safety in the industrial world? Is it maximizing profits? Hitting those tight project deadlines? Maybe keeping the whole thing under budget? Well, the definitive answer is simply preventing accidents and injuries. It's a super easy trap to think about efficiency or budget when you're caught up in industrial management, but the bottom line, and literally the driving philosophy behind every single rule we're about to cover, is saving lives, keeping people intact, period. Moving right along to Section 2, Preparing the Worksite. So before anyone even steps foot on a site with a hard hat, there are 4 sequential pillars of preparation. First, you've got to check the current site conditions. Second, gather the site history. This one is absolutely non-negotiable, guys. You have to know if you're digging into an area that, say, used to hold toxic chemicals or has an unstable foundation. Third is CDM, or Construction Design Management, which basically bakes safety right into the planning phase. And fourth, plan your emergency procedures, because let's be real, you do not want to be figuring out an emergency plan during an actual emergency. You lock that whole shebang down before the contract even starts.
All right, Section 3, Identifying Workplace Hazards.
First up on the hazard list, biological hazards. These are invisible threats derived straight from living organisms in the environment. We're talking bacteria, viruses, or fungi. Now, mentally separate these from man-made industrial chemicals, okay? Biological hazards stem from the environment itself, and pinpointing their common sources is a massive part of any solid risk assessment.
Now, when we pivot to chemical hazards, the exam is going to explicitly require you to know exactly how toxic substances physically get into the human body. So definitely memorize these 4 specific pathways. We have inhalation, so breathing it in, absorption, where it soaks right through the skin, ingestion, which is swallowing it, and injection, entering through a puncture or a cut. Knowing these exact pathways is what dictates the specific protective gear you'll end up needing.
Next up, we've got ergonomic hazards, and these usually aren't your sudden, dramatic accidents. Instead, think of them as physical stressors in the work environment that just cause long-term wear and tear on the human body. Preventing them requires very specific corrective practices and postures, which you'll often see illustrated with diagrams in the safety manuals, all to make sure workers aren't totally destroying their joints or backs over a 20-year career. And finally, physical hazards. These are the direct, immediate environmental risks. To give you some concrete examples you might see on the test, fall protection absolutely must be provided at a height of exactly 6 feet in construction. That's a strict rule. Another key definition to nail down is excavation, which specifically means digging trenches or foundation pits, which of course carries a massive risk of cave-ins. Oh, and overloaded electrical circuits? Those fall firmly into this physical hazard category too. So you might be wondering, how on earth do we keep track of all these specific material dangers on a chaotic worksite? Well, the answer is the SDS, or Safety Data Sheet. Think of this as the ultimate on-site cheat sheet. Its main job is identifying and communicating the exact hazards of any materials used on the site. It ensures everyone knows exactly what they're handling and, crucially, what to do if things go sideways.
Which brings us to Section 4, Mastering Protective Equipment, commonly known as PPE.
But before we physically put on the armor, we actually have to secure the machinery itself. So here's another direct exam question for you. What is the main purpose of lockout/tagout procedures, often just called LOTO, in construction?
The definitive, correct answer here is controlling hazardous energy sources during maintenance or repairs. Imagine someone is inside a massive piece of industrial machinery fixing a gear. Lotto ensures that there's literally no way someone else can accidentally turn the power back on and cause a catastrophe. It physically locks that energy source down.
Okay, now let's talk actual gear. When you're selecting physical materials for specialized protection, you really need to know the difference between these two heavy hitters. Kevlar is your absolute go-to material for impact and cut resistance. Think heavy-duty gloves or vests that stop sharp objects. Nomex, on the flip side, is specifically preferred for firefighting and electrical hazard protection. Why? Because of its truly incredible flame-resistant properties.
Next, let's compare chemical and environmental suits. Tyvek and Tychem are absolutely fantastic for lightweight, often disposable protection against hazardous particles and light splashes. But if you're wading into a highly toxic, really intense chemical environment, you're going to need the heavy-duty stuff. That's where rubber and neoprene come in, boosting that chemical resistance to a much higher standard. And a quick rule of thumb for the exam. Disposable PPE, like a standard Tyvek suit, should literally never be reused.
Now, you are definitely going to be tested on the whole alphabet soup of global PPE safety standards. So let's decode them right now. OSHA regulates U.S. workplace safety. ISO sets the international standards. EN standards are the benchmark for Europe. NFPA regulations dictate fire and flame-resistant garments, and ANSI/ISEA 107 is the vital standard specifically for high-visibility safety apparel. Seriously, knowing exactly what each of these acronyms stands for is a real game-changer for passing the exam and ensuring global compliance. Might want to take a mental snapshot of this one.
All right, our final section, Section 5, Workplace Culture and Bullying. This shifts our focus to the human element. Workplace bullying directly degrades both industrial productivity and physical safety. I mean, a distracted, stressed worker is a dangerous worker, right? The protocols here are strict. They require early intervention and mandate the immediate reporting of any incidents. Management is then expected to maintain strict confidentiality during investigations and enforce real disciplinary actions. Plus, bystander action is absolutely critical. If you see it happening, you are expected to report it to management to maintain a risk-free environment for everyone. Which leaves us with this final, really vital question to ponder. How do all these rules on paper translate to actual human behavior on a busy, chaotic construction site? Management can write the absolute best work health and safety policy in the world and mandate all the right PPE standards, but how do those textbook policies actually survive and adapt in the unpredictable, high-stress reality of the physical world? Honestly, it all comes down to workplace culture and execution. Think about that as you continue going through your study guide. Thank you so much for joining me on this explainer, and best of luck mastering these industrial safety standards. You've got this.